All right, hello. Welcome to the second day of our review of linear functions. This time we're going to do the slope-intercept form. By the end, hopefully you'll be able to identify and apply the different parts of the slope-intercept form of linear equations, as well as graph an equation that is given to you in slope-intercept form. Slope-intercept form, if anybody remembers anything about linear functions, it's always slope-intercept form. Y equals mx plus b. X and y are easy. Those are our variables that we use. They can be altered, changed into whatever for our specific purposes at any given point. Like that plumbing problem from yesterday, we can use c instead of y for cost, t for instead of x for time. But so x and y are just kind of our dummy variables that we just keep around. M and b, however, they keep specific purposes. Turns out, and for reasons we talked about yesterday briefly, that b is our starting value, our y-intercept. M, like I know we said that in the previous video, is our slope. Again, I still don't know exactly why they use m for slope. So let's kind of look how that comes together when we're doing, say, the plumber example from yesterday. Suppose you have to call a plumber and he charges you blah, 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 all that stuff. Our initial price was 100. Oh, this is why I don't like using a mouse for this. So B is 100. Our rate of change, which as we discussed is our slope, is 120. So our equation, let's use C for cost instead of Y, equals 120. And then I'll use a T for time instead of X, plus 1, oh my goodness, 100. Oh, I'll switch over to the tablet here before too long and use that for the writing, because using the mouse is plainly not so good. Yeah. Anyway, the equation comes out C for cost in this case instead of Y equals 120, because that was our rate of change, which is our slope, times time, T in this case instead of X, plus our initial cost, which was 100. That's why that works. Next. Alright, so let's look at another one. I already have this set up, so I'll just struggle through with the mouse right now. Find a different solution for the future. Okay, tree starts in spring at 84 inches tall. It grows a consistent 2 inches a week during the growing season. So we want to write an equation that models this situation. Well, our b value, our y-intercept, which is our starting value, no time has gone by, is 84. So stick in 84. M, our slope, again, is our rate of change. How much are we changing by? 2 inches per week. 2. One thing we'd have to watch for in a lot of word problems is making sure that our units are consistent. You can't have one be measured in inches and the other be written in feet and have the equation work out correctly. So in this case we're okay because they're both inches. All right, let's see here. Let's just use x and y. Y equals our slope times x plus our initial value of 84. So that equation, y equals 2x plus 84, will work for modeling this particular example. Let's switch over here in just a second. The rest of it I do have set up so I can write it. Okay, so I have this line graphed here, and I want to write the equation. So it's the exact same idea as what we were doing with the word problem a minute ago, but starting with the graph. So we have y equals, we're starting our y-intercept at 1, 2, 3. Now that's negative 3. And now we need our slope in there for x. So if we count from one point to the next, we go up. Let me see if I can get that to show up. 1, 2, 3, 4, 5. Up. 1, 2, and over 2. So we wind up with y equals 5 halves x minus 3. And again, all I did, remember that slope is the change in y coordinate over the change in x coordinate. It's not showing up very well right now. Oopsies. How do I get rid of that point? Well, that was bad. So I started here, up 1, 2, 3, 4, 5. So the 5 came from, and then from there, 1, 2 on the x. That's where the 2 came from. Notice also that on this particular program, up here in the corner, has the equation already listed. But they do it in a rounded off decimal instead of a fraction. In this case, 2.5 is fine because that's what 5 halves is. But if I were to do something like, there. Slope of 2/3, up 2 over 3. And as you can tell up here in the corner, it just rounds off that decimal. So you need to be able to know how to do this yourself so you can get the fractions correct. Alright, so let's turn that around now. Let's start with the equation this time and work backwards and do the graph. So let's do y equals 3/4 x plus 2. Okay, well I'll start, my y-intercept is 2, so at 2 on the y-axis, it is the y-intercept. I'll put the dot. Now I need to count off my slope of 3/4. So from this point I'll go up 1, 2, 3. To the right, 1, 2, 3, 4. And y, there we go. So I have this line drawn. And what you would normally do on your paper, unless you have a straight edge, is go ahead and count up 1, 2, 3, 1, 2, 3, 4. A second time, maybe a third time. Oops. Crap. Hopefully this is still working. Anyway, you do it a couple times on your paper, but since this is computerized, all I need are the 2 points. It automatically comes up. Now, compare the equation we started with the equation this program told us, 0.75x. 0.75 is the decimal equivalent of 3/4, so that's correct. Plus 2, same as what we started with. So that's good. It worked nicely. So erase that point and erase this. Let's do one more quick example. Let's say y equals negative 2x plus 5. Alright, so y-intercept 5. 1, 2, 3, 4, 5. Beautiful. Slope is negative 2. So remember that's negative 2 over 1. Always over 1 if it's a whole number. So now we have a negative 2. So we started at that point, down 2. Now do we go left or do we go right? The thing to think about is, with the negative, if we go down 2 and then this way to to the left, that's a negative on the x direction also. So we've gone down to the left, negative divided by a negative. If I put that in, you can see that's a positive number up here in the corner. So that's not what we want to do. We want to come down to the right. Always to the right when you start off, so that way you know what, make sure you're getting it the right way. Just have the negative control up, down, always go to the right. So from this point, again on your paper, you just go down to, dang it, you'd go down 2 over 1 again, down 2 over 1, down 2 over 1 on your paper until you get all the way across, and then you can draw your line nice and neat. So that's pretty much the quick version of reviewing slope-intercept form. Y equals mx plus b. M is our slope still. Rate of change. It's an important key of this overall review. Slope is the rate of change. For linear, that is a constant number that is the same throughout the entire problem. That's how you get a line. And then the b part on the end is the y-intercept, which is usually referred to as the initial value. When x is 0, what does the y equal? Well, whatever b is. So with that, those two pieces of information, if you're given that, you can write an equation in y equals mx plus b like we did in both the tree and the plumber examples. And then if you are given equations with slope-intercept form, then you can graph those. First you plot on the y-axis your y-intercept, your b value, and then you count off the slope, up, down, whatever it takes, always to the right. Get enough points to be able to draw your line neatly, draw it across your paper, and you are done. Now, remember, we're just reviewing how to get this done, not really applying it too much yet. We'll get more to the applications of what our line's good for here in a 2-3 days or so. We got a few more things we want to review first and make sure our skills are sharp before we do that. Okay? All right, that is one more video, so thank you.